Alright, so before we move to the next homework or quiz, we like to see a couple of notations so that we can understand the set of instructions. So at this point, we will try to understand almost every single instructions we have there except a couple of ones. So to understand the instructions, basically we will need to understand the column 3, okay? Column 3 of the set of instructions. Now let me show you what do I mean by column 3 here. Now if you look at here, let's enlarge it a little bit. Okay, if you look at here, look at this column 3 under the description. This basically is the scientific description of or notation of what the instruction does. Okay, now we will try to understand one instruction at a time. Let's say the first one. So to understand this, we have to understand a couple of notations here. Look at this. So anytime, let's go back to that slide. I'll probably give you a copy of this one. So anytime you see A, B, D, those are those are the registers. Now by A we always know there's a content, and that's the content of accumulator, which is 1 byte. Because the accumulator A is 1 byte. By B we always mean that the content of what do you mean by the content? Meaning the data you have in the B, okay, or the data you have in the A. Those are assume the content of the accumulators. And same is the D is the, but remember the D is 2 byte, and there is no physical location of D. There is no register D. Instead, D is just A followed by B. Okay, so D is always we use if you need a 2 byte accumulator, but technically there is no 2 byte accumulator. So what your compiler assumes that you are basically trying to use A followed by B. Okay, so and X or Y, sometimes you will see XY, or sometimes you might see IX, IY. These are index register X and index register Y, and as you know, those are also 2 bytes. By some more registers here, SP is a stack pointer. We don't know exactly the purpose of these registers, okay? You don't also need to know these. The only thing that you need at this point, you'll know it soon for sure, the purpose of all these registers. Now at this point, just we want to see how the instructions are working, and for that purpose, we just want to use the registers, or we just want to understand the instruction by understanding the syntaxes. It's written in the column 3. So the CCR is the condition code register, PC is program counter, and all these are registers basically. Up to here, everything is registered. Now all these registers, you see that all these registers except A, B, and CCR, everything are 2 byte. Everything else is 2 byte each. Okay, except A, B, and C. And one more information is D is nothing but A and B. A followed by B. So the D is 2 byte. So the first byte is basically A. Second byte is B. So anytime you are changing something in D, automatically your A or B will be affected, because that's the same thing. Okay, technically that's the same location. Next thing is, sometimes you might see M. A lot of places you will see M. M means the memory byte. Now what is the memory byte? The memory bytes are the bytes of the, remember the memory map we have in several questions. We give you a memory map starting from quiz 2. We gave you the memory map, and you find some location address there, and you find the content of that address. So those are the memory locations, and so for an example, in general, 1M means it's just 1 byte, because every memory location is just 1 byte each, right? I'm talking about the content. Content is 1 byte, but the address is 2 byte. Okay, address of the byte is 2, but the content, meaning the data you can put inside that memory byte, is always 1 byte. But sometimes you might see this M:M+1. That means it's talking about the 2 byte, consecutive 2 byte. The first byte, next byte. Okay. sometimes, a lot of time you'll see this kind of arrows. This means it's talking about the copying the data from the left side of this symbol to the right side. Let's look at a couple of examples here. Let's say the first one, ABA. Now at this point, let's say we don't understand what it is, okay? To understand it, there are two columns. Those might help you, column 2 and column 3. In column 2, there is a little, plain English description. Sometimes it may not be clear to you just by reading those. Sometimes it may be. But column 3 is like more technical part. So if you look at the column 3 for this instruction, what do you see? It's written A plus B, arrow A. That means what? A and B, the content of A and then content of B is added. Okay? And then is copied to A. Now what happens? For an example, let's say, just to be simple, if you try to run this instruction, as you see, this is an inherent instruction, right? Look at this addressing mode. Inherent, so there will be no, let's say, no operand. Now anytime, let's say you are executing this instruction, let's say you have something in A and something is B. Let's say you have 1, 1 in A and you have 5, 6 in B before you execute this instruction, okay? Now let's say you executed ABA. Now what happens after ABA? So it first adds these two, right? 56 and 11, you are adding. Remember, all these are hex. So 56 and 11 are added. So if you add, this is A plus B, right? We are just doing A plus B, so we are adding. So you will have 67. And then 67 is loaded here again, back here. Because, look at this, arrow A. What does it mean? It means that after you are adding, the data should be loaded to somewhere, right? I'm saying result should be loaded somewhere. And that is mentioned that after you add arrow A, that means data will be loaded to A. So by this, so if let's say somebody give you this question, okay, now let's assume A has 11, B has 56, and you executed ABA, what happens? After you execute ABA, B still remains same, but the A will be replaced by 67, which is the sum of A plus B, right? Exactly, that's how you are going to read it. Basically, anytime you see an instruction, so let me show you another one. Because there are plenty of instructions. I'm not going to by one. We'll just look at which one is coming first. We'll not have everything in quiz 4. We don't have all of these. We have the basic ones first. Let me show you an easy one as well here. Let's say CLRA. Okay. What does it mean? This means clear accumulator A. We don't understand what do you mean by clear. Let's say. Okay. Now let's look at column 3. What is explained there? Look at this. That means you will copy 0 to A. That means whatever the content you have in A, that will be replaced by zeros. That's what I'm saying. So after you run this, let's say after this line you ran CLRA. That means what happens? This 67 will be replaced by 0, 0, because that means by clear, okay? So let's say here, I'm just randomly picking something just to make sure we can read, or at least the basic ones. Let's say, let's look at here, com A, okay? Here is written 1's complement A. Do you think the 1's complement, are you familiar with 1's complement? You are, right? Remember when you did the 2's complement subtraction in the digital circuit class? What do you do in the first? You do the 1's complement, right? Where you basically flip everything. You flip all the digits, right? That was the first step of 2's complement. So that's the 1's complement you do there. But just look at here. What happens? Any guess? What is happening there? Whatever the content of A you have, whatever, you are subtracting that from FF, right? You see it? FF minus A. That means whatever you have in the A. For an example, you have, let's say you have, let's say you have 0, 0, because you just had 0, 0 there, right? So you will be subtracting 0, 0 from FF then. Okay? You are subtracting 0, 0 from FF. Now it becomes FF minus 0, 0, which is still FF, right? FF minus 0, 0. So you have FF and you are subtracting 0, 0, so it still is FF. And that FF is being loaded into A, right? So now this 0, 0 again will be replaced by, FF, right? So you know, this is how you will always see after each and every instruction there will be some change in somewhere, not probably everywhere, somewhere, right? And where you will know it from the description, okay? But remember, at this point, we are not trying to understand every single instruction, but we'll make little step every time. So that's why once we go to quiz 4 now, you will see some basic instructions. I did not include all the instructions there because I know some of the instructions are little bit longer, little bit more than the other ones. So that's why we are trying to understand the very basic one, okay? Each and every instruction you will see something like this. The question will tell you, okay, we have this in D. After this instruction, what you will have in D? Now we know that D means A, B, right? Look at the instruction, look at the description, and see whether you can make some sense, okay? So for an example, let's say if I try here, let's see whether I can. We can pull some of the questions from here. Let's see. The quiz 4. Okay, let's look at one question from here. The first one, let's say. Okay. Let's enlarge it a little bit. Let's check. Can you read the question? Okay. Now here, assume the content of accumulator D is A005. Because the content is 2 byte because the D is 2 byte, right? So what data are loaded into accumulator A by the instruction A D D D 1 2 3. Now let's first try to understand what is given. So you are given these basically. Okay, now let's say this is your accumulator A and this is accumulator B. So at the beginning you are basically told this, because this is D, right? This is what I'm saying, combine. A and B is combined D. So this is what is mentioned, that in the D you have A005. So A0 is basically in A and 05 is in the B. Because the first byte is always in the A, second byte, because you know technically there is no D. Physically there is no D, but the D is logically combination of A and B. Now, what is the instruction you are given here? A, D, D, D. Now anytime you see an instruction, to understand what it is, we always go back to set of instructions. Now let's go back to set of instructions and see what do I mean by A, D, D, D. Okay, we found here. This is A, D, D. Now let's see what does it mean. Look at A, D, D, D here. That means what? Whatever you have in the D, that's content of the D, right? What do you have? You have A005, right? That's already in the D. So A005, you will be adding something from the memory with that. Now what are you adding? You are adding 2 bytes of data, right? Now where you are going to get those 2 bytes? You see 2 bytes here? The m is 1 byte and m plus 1 is the next byte, right? Now how do you get this 2 byte? Now let's go back to the instruction again. What is written here? Do you see 123 here? Now anyone here tell me whether this is an address or data? You know it, right? That's an address because there is no pound sign, right? We all know it. Now since this is an address, can we find this address in the memory location? What is 123 in hex? This is not in hex, right? This is decimal. Now let's convert 123 into hex. Now let's write 123 here. Change it to hex. That's 7B, right? That's 7B. Now let's look back into the memory map to find the 7B. So this is 70, 71, 2, 3, 4, 5, 6, 7, 8, 9. That's 7A. Now this is 7B, and so this 7B is 73, right? This is 7B, right? But how many bytes you need? Remember the 2 consecutive bytes, that byte and the next byte. Now what is those? 73 and the next byte is what? B4. Do you see the B4 here? The next byte. 73 and B4. Do you see it here? So these are the 2 bytes. Now what the instruction told you? Instruction told you to add, right? D plus these 2 bytes. You are going to add. Now what do you have in the D? You had A0, 05, and then you'll be adding what? 73 from the memory locations. 73 B4, right? This is in 73 B4 was the memory bytes, right? Excuse me. Let's go back. Yeah, here. 73 B4. Okay, these are the 2 bytes, right? Oh, because we have to add 2 bytes. That byte, see, you will be always given the address of 1 byte, okay? But whenever you see this m plus 1, m colon m plus 1, that means you will be taking that byte and the next byte. That's what exactly I mentioned here when I explained this. Remember, here, data, 2 bytes, starting from memory location m to next location, basically. Whenever you see m colon m plus 1, that means you will be taking 2 bytes. But you know, the address will be given only for the first byte, because you know we cannot give you 2 addresses. So we'll give you the address of the first byte, but when you will read the memory map, set of instruction, you will know that you will need 2 bytes. So you take that byte, next byte. So now we know that the 2 bytes are 73 and B4. Then we can add, right? 5 plus 4 is 9, B plus 0, B, 3, A plus 7 is 17. You subtract 16. This is 1, carry is 1. Now, let's go back. Let's go back here. Can you tell me where the data is going to be stored? Into D, right? Do you see the arrow D? That means what? After the addition is over, is done, you get the sum, and that sum is to be loaded into D. Now, here, tell me what is loaded into D. You got the sum, right? You already got the sum. Now look at this carefully. This is more than 2 bytes, right? Do you see it? Because up to here is 2 bytes. 13B9 is 2 bytes. But this is more than that. Now what happens in such situation is automatically the carry is ignored. Because it cannot hold the whole thing. So the carry will be ignored. So the data is going to be stored is 13B9. Okay. Now what happens into accumulator A and B? Because this is basically D, right? combined. So basically the A13 is going to be here, and then B9 will be going to. So this is replaced by 13, and this is replaced by B9. Now the question was asking, let's go back to the question again. What was the question? So you now have everything done, and let's see what the question was asking. The question was asking what data is loaded into accumulator A. Now what data is going to be loaded in accumulator A? That's 13, right? So your answer should be 13 then. So the answer should be 13 just. So that's how we will try each question at a time, and every question something will be given. You know, I try to make it as simple as I can. So most of the questions you will see only on A and B, most of the questions. So it will tell you, okay, something is given for D, so that means it's A and B, and then one instruction will be, you will be looking at one instruction, and you will try to understand what that instruction is from the description column, and then do the math. Most of these are like addition, subtraction, either clear by 0, very basic one. So let's look at the quiz 4. If you are done the quiz 3, done with quiz 3. So, and again, you have unlimited chances. So, and all the questions will look like pretty much similar to this one. So, any question? And again, every time you submit, you will see the right answer. Try to see whether you understand it. We are here also to explain it if you don't understand. So now we are trying the quiz 4. Now let's pause it here.